I am Titus from KUHAS, and I am from the Department of Biostatistics, and we'll be here for this training. Yeah.
My name is Farida Iddy from KUHAS, Department of Epidemiology, Biostatistics, and Behavioral Science. So we'll be together in this session. And Mr. Titus will lead a discussion, and I'll be here checking the chats. If there is any question, then I'll just raise a hand if I have any additional points. So maybe we can share and start.
Yeah, sure. So I will share my screen so that we can start our session. And so we will start our session, which is on data analysis, and we'll be focusing specifically on collection, cleaning, and analysis of data. So I'm Titus Leeyio, and we are with Farida here. So if you have any questions, please write in the chat box, and Farida will be there to reply to any questions, or raise your hand, and we will answer to any questions that come across. So you can always raise your hand at any point in the discussion. And this is an interactive discussion, so if you think like you have anything to ask, or if you think like you have anything to comment, make sure you pop up your hand, and we will always respond. And Farida is there to help us in the chat box as well. So before we go far, we need to understand why are we really doing what we are doing? Why are we trying to ask ourselves? Why are we trying to think of analyzing data? Because analyzing data is not something that comes from anywhere. It's something that you think of doing. And you think of doing analysis of data based on information that you have collected. So it's like a series of events that happen until when you are now in the process of analyzing data. It's a series of events, just like the way this workshop or this training has begun. It has begun from different things up to where we are now in day 4 or session 4 of data analysis. So it's a process. So it's an inquiry of asking ourselves, what really problem are we trying to tackle? What problem? What is our interest? What are we interested in? And what do we want to get? What do we want to achieve? What is the problem around the society? And that is what we call a research question. That is what we call our question. That is something that is burning in within us. And then, having had that research questions, we now think of the methods. What are the methods that are guiding us? What methods do we need to get this research question, to get this problem answered? What are the methods? What are the types of data? What are the types of information that we need to get this particular interest achieved? Because it's a series of events, and we cannot really achieve our interest or solve our problem if we have no particular question, and we cannot answer a particular question if we have no data. So in this particular training with us here, we'll be looking at what are the data types, what are the types of data to answer different questions. And then we'll go further and see how can we analyze this kind of data. And then we'll go more further and see how can we obtain the results from this data. How can we give the results? How can we disseminate the results? So it's a process, and it is something that is it comes from your intentions. What are you intending to do? What are you intending to achieve in the society? What are you intending to achieve in your academics? So in this particular point, our main question is, what are the types of data that we can analyze? And what are the types of research questions that can give us specific data that we want to analyze? And then we will ask ourselves, what types of analysis are we going to use? So in this presentation, we will really deal more of the types of data, because already the research questions have already been covered in the previous sections. So we'll really need to think of the types of data. We'll really need to think of the methods. We really need to think on the types of information. And then we'll go on the analysis. So everything else happens as a vicious circle where we start and then we end where we started, and then we'll start again. So it's like a continuous process. And by the way, learning is always a continuous process. The same case to research. Research is always a continuous process, because the moment you find an answer to a question, it's when you also find a question to a more probing answer. So you always have something recycling, something going here and there. Okay, so what are we trying to think? We are trying to think of exploring something. We are trying to think of exploring an idea, and we are trying to think of how can we explore the information that we have. As statisticians, as biostatisticians, our intention is not exploring the universe. Our intention is exploring the data. We are trying to explore the data. Our intention is trying to explain what the data mean, because as biostatisticians, as statisticians, we will have the data, but if we cannot explain what that data means, it will be meaningless. And data can explain anything. You can have data on hypertension and it can explain birth weights. You can have data on hypertension and it can explain glucose level. You can have data on hypertension and it can explain anything. If you have not really specifically explained what your data means. So as biostatisticians and as participants in this session, we are trying to explore our data, and then we are trying to explain. When we say explore, we mean looking at the structure of the data. That's what we mean by saying explore. When we say explore, we are trying to mean looking at the format of the data. When we say explore, we are trying to think of, we are meaning the nature. How is that data organized? Is it a clean data? Is it a raw data? Is it data, secondary data? Is it primary data? Is it data that is quantitative? Is it data that is qualitative? These are the terms that we will meet as we get along. But in this particular moment, we will focus ourselves to what are we trying to explore in this data? And then how can we explain the contents of this data? So if you're given a certain data, if you don't explain that data, somebody said data will always tell you anything as long as you torture it. Meaning as long as you subject that data to a particular pressure, it will always tell you anything. And that is why we've been having misleading conclusions based on data that has been explained wrongly. And so if that data has been explained wrongly, then we need to evaluate and see, how do we evaluate that data to achieve what we want? How do we evaluate that data? How do we weigh down? How do we see the goods and the bads of saying there is 80% prevalence of HIV in Tanzania, and yet that data was used wrongly? So we need to see on how we can evaluate the particular data that we have. And then more, we now need to reflect that data into the experiment that gave us the data. So we need to reflect, we need to test that data and see, what is this data really meaning? So it is an experiment that we are performing in the analysis and seeing, like, are we really achieving what we want? So analysis is all about testing to achieve what you want. So analysis is always about testing to achieve what you intended or what your hypothesis. We have had sessions on hypothesis. So we are trying to experiment our hypothesis and see, like, Are these hypotheses actually getting to the point where we are satisfied with them? Are these hypotheses getting up to the point where we can achieve meaningful information? So overall, what we are trying to say in this slide is we are trying to say, what will your research achieve? Will your research explore? Will your research explain? Will your research evaluate? Will your research experiment? So these are the questions that you need to ask yourself before you even go and collect data. Because this session is all about having questions on what data do we need to collect. So will your research explore? If your research will explore, then what type of data are you going to achieve? What types of data are you going to get? If your result will aim at explaining, then what are you going to get? Are you going to get qualitative data that will tell you the phenomena around and everything else, the theories and the themes? Are you going to evaluate? Is your research aiming at evaluation? So having known that, that will help us determine what types of data we're going to collect. That will help us to determine what type of information are we intending to get. That will help us determine what type of data are we really interested in as we conduct our research. Now, in this particular moment, having tried to see on our exploration and experiment and evaluation, so we'll ask ourselves the basic data types that we need to know. At this moment, universally, along every place across the world, across every other place that you know, every statistician, every biostatistician, every student, every analyst knows these types of data. So it's like we have two major types of data. Back then in primary school, we would have secondary and primary data. Now, in this particular case, we are not talking about secondary and primary data because all of them are data. But now here we are talking of what is the nature of that data. You see, we are talking of what is the nature. How is that data? How can we tell it as we hold it in our hands? How can we tell it? What is its nature? Is it data that is categorical? Is it data that is numerical? Like, is it data that can explain levels? Or is it data that can explain sequence or series of things? So when you're talking about categorical data, we are talking about data that is in levels, different levels. We'll get into examples in the next slide. But in this case, we need to understand that when you're talking about categorical data, you're talking of data that is in levels. For example, we can say educational level. Education is a variable that is in categories. Do you have any questions?
No, we don't have.
Okay, fine. So education is data that is in levels. So that is categorical. So anything that occurs in levels is categorical data. Anything that you can say there is this level and this level. So for example, cancer. Cancer is a categorical variable because we can have cancer stage 1, cancer stage 2, cancer stage 3, cancer stage 4. So education as well is marital status is a categorical variable because we have married, we have singles, we have cohabiting guys, we have divorced and widows and widowers. We have all sorts of people in different marital status categories. So anything that is in form of a category, like one group, another group, another group, that is categorical. So students, for example, there are students at the first year, there are students in the second year, there are students in the third year. So we'll group those students into their categories. And then on the other side, we will have a numerical data. A numerical data to say is any data that is in form of numbers. So on the other hand, categorical data was any data that is in form of numbers. Further, we'll go and see like this categorical data, any data that is in form of words. So we'll go and see how can we transform this data that is in form of words into numbers. But when you talk about numerical data, on your right. Numerical data is any data that is in form of numbers, meaning we'll have different set of numbers, and then these numbers are what we call numerical data, because we cannot say like 1 as a word and 1 as a number to be different. That is only 1. So numerical is any data that is in form of numbers, and categorical is any data that's in form of words. But to be specific and to be more precise, categorical data is any data that can be put into levels. But numerical data is any data that occurs in terms of numbers. For example, we'll have temperature, we'll have height, we'll have BMI, we'll have hemoglobin, we'll have time, etc. So those are numerical. Now, coming down in the numerical wing, we'll have 2 types. We have interval and we'll have ratio. Interval data is any data that has bounds, like 1 to 2. Okay, so temperature can be from -5 to 5. Okay, and ratio is any data that can be compared. Okay, that we can compare. We'll get into examples in the next slide. While on the other side, categorical data, it can be nominal data or ordinal data. When we say nominal data, we mean data whereby the ordering, like this level, from the first level to the second level to the third level, the ordering does not really matter. Being in the third level does not make you inferior to somebody who is in the first level. So nominal is data that has levels where the ordering doesn't matter. The ordering is not important. But ordinal is data where the ordering matters. Okay? Ordinal is where we have data where the ordering matter. For example, education. Education is an ordinal categorical data. Why? Because somebody who has primary level of education, you cannot compare that person with somebody who has a bachelor's degree. So primary level of education and bachelor degrees, there are 2 different categorical levels. So that is an ordinal data. So an ordinal data is a data where the order matters. In other words, the order is very important. So, and how do you identify these types of data? To ask ourselves. We identify these types of data between ordinal and nominal by checking on the importance of the levels. For example, we can say causes of disease. Cause of a disease, any cause is fatal. So we cannot say like cause of a disease maybe from a car accident is more worse, is more bad than cause of a disease from drinking dirty water. So that is, those are levels where we cannot say the order matters, okay? But when we come to employment, employment is an ordinal categorical data because being unemployed is quite different from being employed. So we identify those types of data in that manner, looking at the nature of that particular data. So let's get down. So like we said, we had a series of data in statistics, and we said we have categorical and numerical. Now here we're introducing two different terms. We're introducing what we call qualitative and quantitative, okay? We're introducing what we call qualitative and quantitative. Why are we introducing this? We're introducing this because we have qualitative research and quantitative research. So as a statistical student, you should understand the difference between qualitative research and quantitative research. Now, qualitative research or qualitative data is any data that involves more of words, okay? More of information, words, sentences, themes, and something like that. But when you talk about quantitative is data that involves numbers, words, something like that. So quantitative data here, these are data types which involves words, numbers, figures. That is quantitative data. And this quantitative data, we can narrow it further into either discrete or continuous. As well as qualitative data, we can narrow that data into either nominal or ordinal, okay? So we can narrow that data as either ordinal, or we can narrow it as either nominal. So like we said, we have different types. Now in qualitative data, because we said qualitative data is all about words, so qualitative data is almost the same as saying categorical data, while numerical data is also the same as saying numerical data, okay? So these are just, say, like synonyms or words that mean the same thing, something like that. So these are the types of data that we need to understand before we get into the analysis. We'll get into a practical just right away. And before we get into the analysis, these are the types of data that you need to understand. Okay? And now we need to understand, how do we measure these types of data? How do we measure these types of data? And these types of data can be measured either as a ratio or as an interval, okay? We can measure these types of data either as a ratio or as an interval. So it's like measuring these types of data. So this one is not strict to either categorical or numerical. No, it's just measurement scale. How do we measure this data? But in reality, all categorical data are only ending up to this point. We only end at nominal or ordinal. But numerical data is when now we can go down and see, how do we measure numerical data? We can measure numerical data either as a ratio scale or as an interval scale, okay? So let's get down and see what we have. Farida, do you have anything to add?
No, I think you explained everything clearly. But I guess too we'll have more explanation based on the examples, and maybe we might have questions from students. But what you have explained, you covered everything. And on my side, there is no question in here in the group chat, and I don't see any hand raised.
Okay. In that case, we'll continue. Just a minute. I see my PowerPoint has stuck. Allow me to stop sharing in the meantime.
Yeah, maybe we can just take and share.
Okay. Okay, I'll share my screen once again. So I hope all of us are here again. So here we are. So we are trying to look at the examples of different data types. And in this particular scenario here, categorical, these are the examples of categorical. I don't know how we will say sex or gender, I don't know. But you can say sex in your place, or you can say gender and educational level. These are types of categorical data. And then on the numerical data, we'll have either weight or temperature. These are just examples, okay? You can add your own examples based on what you think. And then nominal data, We can have regions, like saying Dar es Salaam is better than Arusha. You need to have a reason, like why are you saying Dar es Salaam is better than Arusha? Otherwise, Dar es Salaam and Arusha are all the same, okay? You have to say in terms of either administrative or economic or social culture or something like that. So basically, what are you trying to say here? You're trying to say that in nominal data, for you to say one level is better than the other, you need to have reasons and say like, okay, hair color, having white hair is better than having black hair because of a disease. Getting a road accident is more worse than drinking dirty water, or it's more worse than having an infection transmitted to you through either anything else, blood or something. So nominal data, these are examples, and you can always add your own examples. And then ordinal data. Ordinal data, we have different categories. So ordinal data here, we have BMI category, cancer stage. We can have any other data that you think is ordinal, but you need to explicitly confirm yourself that this is an ordinal data, okay? So these are just examples that you are having here. And then when you come to continuous data, we can have height, weight, blood pressure, BMI, glucose level, hemoglobin level, everything else that is continuous, meaning it is data that occurs in a series of numbers. You can have 1, 1.1, 2.5, 6.7, 12.8. Data that has decimals is what we call continuous. So like we can have a height of 1.6 meters. We can have a height of 20 meters. We can have a blood pressure of 93.5, okay? 46, 62. So anything that has a decimal is what we call a continuous data. Then when you come to discrete, is any type of data that does not have a decimal. It stands on its own. Okay. Number of live births for a woman. How many number of live births has this woman given? She has given 5 live births. We cannot have 5.1 babies. We'll have 5 babies, 2 babies, 3 babies. So discrete data is data which has no decimals. Okay. Number of students in this class. For example, number of students in this class. We can see we have around 36 students in this class. So we don't have 36.1. So if somebody leaves, we'll have 35. But we'll not say like we have 36.1. No. So discrete data is data with no decimals, while continuous data is data with decimals. Okay? Is data with decimals. Okay? That is the clear difference between the two. Now, when we come to the scales of measurement, we'll have 2 types of scales of measurement. We'll have the ratio scale as well as the interval scale, okay? Now, what happens in basic research? What happens in basic research? What happens in basic research is we go to the field, we collect data, and then we'll come and find ourselves like, why did we collect this type of data? How can we measure it? How can we understand it? Okay. How can we measure this particular type of data? So that is what happens. And so in this particular case, we need to understand the different types of measurements. Okay. So we'll have the zero, the measurements with no zeros, and we have the measurements with zeros. For example, we'll have height. Height is a measurement. We have gone to the field and taken anthropometric measurements of, say, children less than 5 years, and we've taken the anthropometric measures for calculating BMI, stunting, oh no, not BMI, stunting, wasting, underweight, okay? So those measurements, we'll see which measurements include zero and which one doesn't include zero. So measurements which do not include zero, those are called measurements which are measured on a ratio scale. And measurements which include zero, those are measured on an interval scale, okay? Those are measured on an interval scale. So understanding the whole concept now will help you during the analysis to critically analyze your data, to critically analyze the data that you have, so that whatever information that you're trying to share to people, you are sharing the information correctly, okay? So if you analyze an ordinal data in form of a nominal data, it will make you have ambiguous interpretations. It will make you have ambiguous, bad presentations and misleading conclusions. Because as researchers, as medical students, as medical personnel, affiliates, we need to make sure that whatever that we are trying to tell to the world, we are trying to tell to the world something that is relevant, something that is feasible, something that is practical, something that achieves and solves our problems. So if we have a continuous data that we interpret it as a discrete data, okay, it will make us have wrong conclusions. If we have a discrete data and say like we had 20.5 participants in this study, no, we cannot have 20.5 participants. So 20.5 is a continuous data, but you have interpreted it as a discrete data, okay? Okay, so that is the clear cut that we are trying to point out here. We are trying to point out here that if you know these types of data in statistics, it will help you analyze your data correctly. It will help you during your cleaning. We will have an exercise on cleaning. So it will help you during your cleaning. It will help you during your interpretation. And it will also help you during your proposal for recommendations. What recommendation are you trying to tell us? Are you trying to tell us that people who died from infections are better than people who died from road accidents? That means it's like you're trying to convert a nominal data into an ordinal data. Are you trying to tell us that having black hair is more better than having white hair or brown hair? Are you trying to tell us that being in certain religion, being a Christian is better than being a Hindu? Or are you trying to tell us that religion is an ordinal data? No. So you need to understand critically these types of data as you get along to your analysis, as you get along to your working, as you get along to understanding your research questions, as you get along to answering your hypothesis, okay? So
Before
let us
you
go to,
proceed,
yes.
there is a hand raised by Hidaya Kasim. Can you speak out?
Yes, welcome, please.
Thank you, sir. When you were explaining about the ratio scale and interval scale, no zeros and presence of zeros, do you mean like in the presence of zeros and absence of zeros, is it like 10, 20, that's zero there, or is it like 0 point something? What kind of zero?
Okay, Farida, can you respond to that, or I can respond?
Okay, I'll respond.
Yeah,
The
sure.
zeros that we are meaning is just as zero as it is, not in 10 or 20 or 30. It is just zero. And the reason behind it is in a ratio scale, that means we are dividing something. Maybe you are, for BMI, we always take height divided by weight, if I'm not mistaken. Then that will not be, even if we just divide it, we will not have zeros. And in interval, we might have zeros because it will just be from this point to this point. So that is why in ratio scale, we don't have zero, but rather in interval scale, we have those zeros. I think I respond to your question.
Okay, so what I understood is like the answer of whatever it is that you're manipulating or calculating, or the data that you have it's either the number zero or the absence of the zero, meaning it's 1, 2, 3, 4, right?
Yeah, sometimes it might be
Oh.
1.2 or 1.4, 1.5, etc.
Oh, okay, thank you.
Okay.
Yeah, but also to add on, Thank you, Farida. And when you talk of no zeros, it means we will count from 1 onwards, okay? But when you talk about presence of 0, it means you can count from negative, okay? So for example, temperature, you can count from negative. So there is a 0, that is -1, 0, 1, you see? So that's 0 in between. And one of the things that you need to understand is that an interval scale, you cannot divide an interval scale because there is a presence of 0. Unless when you know that this interval scale has no 0, it means it includes only the positive numbers. But a ratio scale always includes the positive. So that's the logic behind. When you talk about interval scales, it means it can include either positive or negative. And once we have negative, it means there is a 0, because there is a middle line of the 0. If you remember the number line that you were drawing back in class 6 or something, we have the number line and we had the 0 in between. So that 0 was giving us the interval from the negative to the positive. But you remember the ratio scales? We were not dividing anything by 0. You cannot say 2 divided by 0. Okay, those were the ratio numbers. Okay, so those teachers did not just tell us this logic behind, but actually that's what we knew as we grew up. And we cannot divide anything by 0. Why? Because that's a 0, is a ratio scale. But in interval, we have zeros. Thank you so much for your question.
Thank you too, sir.
Good. So let us dive a little bit on characteristics of a research question. Now, you might have met characteristics of a research question back then in session 1 or session 2 or session 3 or something, or you might probably meet them as you get along. But here we are trying to think of how is this research question related to your particular data? That's what we are trying to narrow down here. And how is this research question going to answer your questions in the field, in your questions in research, as you get along analyzing your data? So it's like trying to analyze your data to answer questions. And so how are we going to analyze our data? And what are the characteristics of the questions that we'll be having in mind? Okay, so your data should be limited to a single problem to begin with, okay? So you cannot have that data that you say, okay, this data will answer questions on hypertension. The same data will answer questions on food problems. The same data will answer questions on preterm birth weights, preterm birth. The same data will answer questions on cardiovascular problems. No. Your data should be limited to a single problem. You have data on cardiovascular problems, so you're trying to check on cardiomyopathy something, so you have your data on cardiovascular things. You have data on low birth weight of babies, you have your data there. You have your data on hypertensive adults, you have your data. You have your data on HIV, different phases or something, but you cannot just say like, oh, I have my old data here that will answer every problem that you have. Hey guys, what problem do you have? No. You cannot always go like that. We'll have data that answer single problem. And that is why if you go to DHIS data, the DHIS data contains every other thing, but they have classified into different problems. So the DHIS data contains everything. It's a universal data, but it has been classified into single problems. Okay, and then having your data, you should be able to find the answer using data collection. Okay, you should be able to find the answers as you collect your data. You should be able to guess the answers. You should be able to guess the possible answers as you collect your data and see like, why do these women why is there prevalence of low birth weight? Why is it so high here? So as you collect data on women, you should now getting hints on their feeding habits. They're not attending to the antenatal care clinics. They're not having good rotation on their trimesters and everything like that. So you should be able to answer questions as you get along collecting your data. Okay, and if we have any problem, you should be able to understand your particular data. Okay, so that particular data limited to a single problem, it should provide a detailed information on the results. Okay, should provide a detailed information. It should also be able to answer questions. Okay, should be able to answer questions, and then it should be realistic. Okay, just another point that we have forgotten here, that it should be smart. When we say smart, it means we are saying your data should be systematic. Okay, that is S. Your data should be systematic. Your data should be measurable. We should be able to measure from your data. Okay, we should be able to measure from your data. We should be able to say that your data is accurate. Okay, we should be able to say that your data is realistic. And then we should be able to say that your data is time bound. Like, when did you collect your data? I collected my data between 1st January and 31st December. So it is time bound. Okay, we cannot have data that is collected every other time. Why? Because human beings change. And as biomedical students, as biostatisticians, we deal with human beings. So you will say like, okay, I'll keep on collecting my data as I get along until I finish my MD5 or something like that. So in the course of being in MD3, your participants have changed their behavior. So you can no longer collect your data again. So that's why we're saying that your data should be time bound, okay? And it should be very relevant. When we say being relevant, it means your data should accurately talk about your research problem, okay? Your data should say, what is your research problem? You cannot tell us that your research problem is like looking at the prevalence of HPV among women, and then you go and collect that on men, okay? That is not a relevant data set. So if we are talking about HPV, we expect to see a variable of women in your data set. We expect to see gynecological findings in your data set. Okay, that's a relevant data set. If you're talking about, if you're trying to see on the prevalence of, say, cholera in a certain city here in Tanzania, we expect to see your data containing variables on WASH. Okay, that is a relevant data set. But you're saying that you're trying to look at cholera, and then we are meeting variables like BMI in your data set. That's not a relevant data set. We are meeting variables like blood pressure. That's not a relevant data set because it does not tell us what information you are gathering. It does not predict the future. It does not predict the solution to an existing problem. So it should give light, okay? So your data set should give light to an existing problem. It should give light to something. So as we get into the analysis, as we dive deep into the analysis in the next session, you should first of all see, are you seeing light in your data set? Can you guess a solution having your data set before analysis? Okay, and so that solution should be resolvable within the time limit. Okay, you should be able to resolve within the time limit because data expires. Get into your mind that data expires. Okay, so for example, we cannot use the census data of 2012 now because it has already expired. Okay, we cannot use demographic health survey data of 1997, for example. Why? Because it has already expired. So this data expires, okay? So you should be able to resolve within the time limit and other restrictions. For example, prevalence of a disease. For example, you cannot use data on COVID-19 now. Why? Because it has already expired. COVID-19 has already passed. We are no longer talking of COVID-19. We are talking of wars and other communicable diseases, okay? So you cannot use data that you collected in 2019 on COVID and say like you want to answer questions now. That is a restriction. Time is a restriction, okay? So your data should be resolvable within the time limit. So as you get into your research in your next year or in your final year, or if you're currently doing your research, you should make sure that you're collecting data that is resolvable within the time limit. You should make sure you're collecting data on a women at that particular point. Not that you wait for a woman to go home and finish their they're breastfeeding. After 2 years is when you come and collect data on that woman concerning their delivery problems. You won't get that particular data accurately because that woman has already gone and time has already passed. So that woman will forget. It is likely that that woman has forgotten what has happened. She will only remember the bills. She will only remember the high bills at the hospitals and the harassment and the in the wards. Okay. Finally, your data should reflect your chosen field of study. This is very important to understand for us because as students, as academicians, we should make sure that whatever field of study that we are, our data should reflect our field of study. I'll give an example here. We are all studying medicine, for example. So if you're studying medicine, we don't expect you to go and collect finance data. We don't expect you to go in the BOT and to go in the banks and say, okay, fine, I'm trying to collect data on finances. How many people are paying taxes down here? And everything. No. We expect you to collect data based on your field of study. That is the first point. The second point is we expect you to collect data on what area of study you are doing on. For example, I am doing a study on malnutrition, okay? So I'll collect data on malnutrition. There's no point where I'll say, no, let me add something. Let me stop malnutrition and then I'll go and collect data on something else. No, my data that I'll collect should reflect malnutrition, okay? If I'm trying to collect data on maternal health, then the data that I collect should reflect maternal health. And not that I say, no, because maternal health is about women, I can also collect HIV on women. No. It should reflect my field of study. It should reflect my area of research. It should reflect my problem solving in the area where I am. So as you get into the analysis, you should just try to see, is this data really reflecting my field of study? Is this data really trying to solve what I'm trying to achieve? Is this data in that line? So these are the characteristics of a research question that you need to be answering as you get into the analysis. So when you get into the analysis, you should start seeing such information. You should start seeing such kind of characteristics and see, where am I lacking? Where am I missing? In that particular case, now you can rephrase your whole documentation. So finally, let us look at the process of data analysis. This is what we'll be going across. This is what we'll be doing. We'll start with identifying the data that we want. Okay. What data do we want? Okay. What data do we want? We want data on gestational periods of women. At what time did they deliver? Did they deliver at 6 weeks, 26 weeks? Okay. What data do we want? We want data on maternal health. Okay. We identify the type of data that we want. What type of data do we want? We want data on genomes and genes. Okay. We'll try and see. We want to identify the particular data that we want. That is the first stage. And this is primarily because it will lead us as we get along to try and answer different questions in this slide. So the type of data that we want will help us get down into these characteristics and see, are we really going to achieve a smart solution? When we say a smart solution, we are saying something that is systematic, measurable, realistic, accurate, and time-bound. That is smart, okay? So we need to identify the type of data that we want. Do we want data on women, data on men, data on people in the ICU? That's the first thing. And the second thing, we look at, how do we collect this data? What are we using to collect this data? We might have a session on data collection tools, but we need to ask ourselves, how are we going to collect this type of data? Okay. So are we going to the field and say, like, having questionnaires, people filling in the questionnaires? Are we sending questionnaires to people randomly in the email or something, the phone call? Are we going to the hospital systems and extract data? That is called secondary data. Are we going to the field and getting primary data? How do we collect this data? So we will have the first step as identifying the data that you want. The second step is collecting the data. So in this collection of data, you should make sure that you're very keen, because in this fifth characteristics here, we should be very strict to time. If we are not strict to time, then we might collect data that is not relevant. Okay? How do we collect the data? Is the data relevant? Is the data good? And then the third stage is the cleaning process. The cleaning process is another session for its own time, but to be aware of, you need to define your parameters so that as you get clean, you can remove all unwanted information that people might have collected. Okay? So cleaning the data is not about wiping everything else, but it is about removing unwanted information that might jeopardize your analysis. Okay, so cleaning the data is all about removing information that might mislead you. Cleaning the data means removing information that might distort your findings. Okay, so we are cleaning the data. We are not wiping the data off, but we are trying to see what information did I collect wrongly. So I need to remove that. And in removing that, we are not throwing it away, but we are just creating a copy of the data set so that we have a raw data set and a clean data set. So that in the meantime, as you get into analysis, if anything changes, your mind shakes a bit and think like I need to the raw data set, you go back to the raw data set. So what we do normally in the cleaning stage, in the cleaning process, is we create a copy of the data sets. Okay. So we have the first data set that we collected in the field or in the databases, the hospitals and everything. That's a raw master, that's a raw data set. And then we do a copy. So we will be cleaning the copy and not the original data set. So we'll be cleaning the copy and removing unwanted information from the copy, okay? Unwanted information from the copy. And then I can see a question here by Powell. Can cleaning data manipulate data to the desired researcher? Yes. One thing is you should always be careful when cleaning the data. Farida will have a note to write there, but you should always be careful not to clean the data in the direction where you want, okay? Like you're cleaning the data and saying like, okay, I'm cleaning this data so that I can have what I want. No, 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 no. You clean the data in a desired manner, because cleaning the data in your direction means you are cooking the data, okay? So you should clean the data in a manner whereby you are not favoring the data, okay? Somebody filled 2, and then you say, no, 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 because I need 4, you write 4. No. If somebody filled 2 and you think it's a wrong thing, you can always retain it or have something to think about that. Somebody filled 24 and you think like, no, 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 I don't need 24. I need 30. You erase 24 and write 30. That is not cleaning. That is mining. You are mining the data. You're trying to torture the data, okay? Cleaning the data means removing unwanted information that has been collected, not changing the information. No, 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 no. It is removing unwanted information that has been collected, okay? We can change information when we think like somebody was trying to write a very accurate guess. For example, we are saying, what is your height? And somebody writes 247. We exactly know that 247, nobody is 247 meters high. So we think like, okay, that can be 2 meters and 47 centimeters. So we convert that from a discrete number to a numerical number, to a continuous number. So we say, okay, we can clean this and say, instead of 247, it can be 2.47, okay? Somebody writes, what is your, for example, what is your weight? And somebody writes 900. We know there's nobody weighs 900 unless that person is an elephant. But we know somebody can weigh 90 kgs, 90 kilograms. So we can clean that and convert that into 90 kilograms, but not say like, no, 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 I cannot have 90 kilograms, 9. No, no, no. We can say 90 kilograms. So we are collecting weight on babies. We don't expect to have a baby weighing 50 kilograms. Okay, so we get into our data and we say like we have 500. And I said, no. This somebody was trying to write 5 and not 500. So that is what is cleaning. It's not changing the data to the desire of a researcher, but it is removing unwanted information. Okay, having cleaned the data, we go to the 4th stage, which is the analysis. Analysis of the data, we'll get into the analysis session, which talks of the methods of the analysis, but you analyze the data having a guideline. There is a standard operating procedure that you need to formulate. You need to formulate your standard operating procedures. You need to formulate your data analysis plan. Data analysis plan is all about what are you analyzing? What is your objective? What is your outcome? What are your explanatory variables? When we say explanatory variables, we mean variables that explain your outcome. Okay? When we say explanatory variables, we mean independent variables that explain the situation that you're trying to study. So, for example, a very common explanatory variable is age. Age is an explanatory variable. Sex is an explanatory variable. Education is an explanatory variable. So explanatory variable is a variable that causes the outcome, okay? And so lastly, we go to the interpretation of the results. So when you talk about interpretation of the results, we look at how do you, first of all, how do you disseminate the information? You can disseminate your results as in graphical formats. You can disseminate your results in tables, and you can disseminate your results in words, okay? So you disseminate your result. You give us your result, okay? And you say like, these are my results. So if these are my results, then you say now, okay, fine, these are my results. So I can draw maybe pie charts for you. Okay, these are my results. I can present in terms of pie charts. These are the percentages, or I can have graphs. Okay, I can have graphs. These are the graphs, the bar graphs, or I can have something like certain graphs that show different dissemination. And then finally, you now interpret your findings. Okay, you're trying to interpret like, okay, you see this? This means that 20% of the women here are HIV positive. You're trying to interpret the results, okay? You're saying what the results mean. You're trying to say, what do those results mean, okay? That is what we are trying to say, interpretation of the results.
Sorry, there is another question.
Yes. Welcome.
It says that cleaning include recollection of data, perhaps because the questionnaire was poorly answered or answered incorrectly.
Okay. Recollection of data is not cleaning, because when you go and recollect data, you will collect raw data. Bear in mind that anything that is called collection of data includes acquiring raw data. So recollection of data is not cleaning. When you talk about cleaning, we are talking of having raw data and manipulating that data, playing around with that data. So recollection of data is a different way of say like let me go back and collect my information. Okay, it's like somebody who have eaten and they feel like okay, I have not get satisfied with this food, and I go and eat another food. They have not changed the type of eating, but they have only changed the type of food. Okay, so what you're talking about here is recollection of data is not cleaning. Recollection of data is another process of getting raw data. And if a questionnaire is poorly constructed, then it means we will have that questionnaire pre-tested, okay? So there is what we call pre-testing of questionnaire. When you construct your questionnaire, for example, you have your questionnaire set, and you say like, this is my questionnaire. Before you take your questionnaire to the field and collect data, you need to pre-test your questionnaire. So you can pretest your questionnaire among your friends. You can pretest your questionnaire with your supervisor. You can pretest your questionnaire with 1 or 2 participants of your study, okay? So you pretest your questionnaire and it's like, is this questionnaire actually helping me achieve the desired data, okay? Is this questionnaire helping me achieve the desired data? If it is not, then you can always adjust the questionnaire. You can always change a little bit about the questionnaire. If it is answering, you say, yeah, this questionnaire is good. So you can now go and collect your data, okay? So cleaning data means you already have the raw data and now you want to make it usable for analysis, okay? You make it usable for analysis. Thank you so much for the question. Okay, so I think we are towards the end of our presentation, and I'll stop sharing for a minute. So we will introduce. I will introduce a starter to you here. I will introduce a starter to you here, and before I introduce, yes.
I just wanted to explain a bit in cleaning data.
Yeah, you
In
can share
cleaning
your
data,
screen.
just always it's not always correcting. Sometimes it's removing some variables, and
Yeah.
we are removing variable when does not, because in everything, those are just datas, but you have to think critically if it is clinically relevant. Sometimes you might have maybe a birth weight of 0. This is not real in reality. So you can just remove that data if you don't have a questionnaire, or even in the questionnaire, if it is reported as 0, then you just need to remove it because it is not clinically relevant. So this process of analyzing or cleaning, it's always about, you have to connect between clinically and statistically. So sometimes the result might be statistically okay, but clinically not okay. For example, if you obtain maybe it is from your analysis, you perform analysis, and then it suggests maybe child gender can determine malnutrition. Yes, it's statistically, maybe it can be statistically significant, but it is not relevant. So I just wanted to add that on data cleaning. So maybe we can just proceed in the starter introduction.
Yeah,
So
thank you so much, Farida. Thank you so much, Farida. This is the step-by-step guide where that we are trying to talk: identification of a problem, data collection, data analysis, and data interpretation. So this is a step-by-step guide. So since you have no questions, I will share I will introduce starter, and then for the remaining few minutes, and then we will pick up from where we will stop in the next session, okay? So let me share my starter screen.
I hope everyone has starter.
If you don't have starter, you can always ask for help from your neighbor, or you can always ask for help from us. So this is a starter window, okay? This is starter window, and this is a starter version 17. You can see the version here. It is a starter version 17, okay? So you can see the version here. So this is starter version 17. And here in this side, we have the commands. In this side, we have the commands. This is where we see the commands. Okay? This is where we see the commands. And here is where we will see our variables. Okay? Our variables. This is where we'll see our variables. And then coming down here is where we will write our commands. So we will write our commands here, okay? And then here is where we'll see the properties. So these are the windows. And then finally, our results will be displayed here. Here is where we'll have our results. We will have our results being displayed in this window here. Okay, so this is the basic layout of Starter. You should understand this basic layout. Some people might be having Starter 17. It's very perfect. The latest version is version 18. So if you have version 18, good to go. If you have version 10, 11, 12, 13, 14, it's good to go. It's good to go. It's good to go. So let us go to now looking at how do we import data, okay? So having seen this format of Starter, let us look at how do we import data, okay? So you can use Starter in two ways. The first way is you can use Starter by typing your commands down here, okay? You can use Starter by typing your commands down here. But you can also use Starter through the GUI, what they call graphical user interface. That is dropping. So if you see, for example, statistics, we have lots of analysis that you can do. We can do thousands and thousands of analysis down here. So you can always use the drop-down menu. That is graphical user interface, okay? So you can do a lot, okay? You can do a lot in the statistic. You can do a lot, okay? You can do so much. You can do so much here. If you are not a friend of writing commands, you can always do what you want from the statistics, from the graphs here. You can draw different graphs that you want here. So you can always do the click, 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 and everything happens. If you are bothered and you don't need all this, you can always close them from here, okay, and they disappear. You can always close them. If you want a floating command panel, you can click this one and it becomes floating. And if you want it, you can always click it, okay? And it comes up and you pin it, okay? So you pin it. So you can always choose what you want. If you don't want all these things, you can always close them. If you want this wide, you can change this so wide. You can manipulate your Starter, okay? If we want everything that was here to be back, we will go to the windows and we will select them from here, okay? So for those who are computer experts and everything, you see we have the shortcuts that we have been given here, the Control+4, the Control+3, the Control+2. These are the shortcuts for those experts in computer. You can always use the shortcuts. And so if you want them back, we can always click Windows, Variables, and we can see we have the variable panel. If we have the properties, you can see the property panel. And so one thing that is very interesting here, guys, I want us to be very careful here. You see, here we have the properties. So it tells us the name of the variable. It tells us the label of the variable. We'll talk about the labels in the next few minutes. And then here it tells us the type of the variable. The types that we've just covered recently in a few minutes ago. It tells us the type of the variable. What type of a variable is it? Is it a continuous? Is it a float? Is it a double? It tells us the type of a variable. And then it tells us anything that is related to that variable. So this is very important here. It tells us all the information that you need about the variable. Its size, the memory that it occupies. It tells us everything else, okay? So that is very important. So that is how you can play around with your Starter. So before we import data sets, I want us to learn the following windows, okay? In this toolbar here, we have the open, which is the file. We have the print, the normal print that you have in Microsoft Word and something. And then we have the log, okay? We have the log. So the log is like a rough paper where your results will be stored, okay? Where your results will be stored. So whatever that you write, your results will be stored in the log file, okay? That is the meaning of a log. We will open it, okay? And then we have the viewer. The viewer is like you want to view in a bigger window or something. You want to zoom or something like that. You have the viewer, okay? And then we have the do file. This is where I want us to concentrate. I want us to concentrate on the do file. Why? Because the do file is where we will write all our inputs, is where we will write all our thoughts. The do file is where we will write all our commands. So I will discourage you from writing here. In the meantime, you can write, but as you grow, I will discourage you from writing in the command window down here. Why? Because you cannot store these commands. Once you write them here, for example, I write a certain command here. Let me say like, for example, log. So these are commands, okay? These are commands that I've written here, log using. But I can always erase this command. I can clear it, okay? I can clear it, you see? I've just cleared everything here with a command called CLS. So what I want you to understand is you need to understand the do file, because from the do file is where you can always write your commands and save the do file. So if you save the do file, you can come back to it 1 year later, 2 days later, 5 months later, and just run the do file, okay? And then here we have the data editor. So if we want to edit our data, we can always click our data editor. If we want to view and see the data, we can always browse it. And then here, if we want to see the variables and manage them, change their naming, change their structures, here we have the variable. So having said that, let us quickly dive into Starter and see how we can import data. Unless anybody has a question. Okay, no question.
We don't
So,
have any question from the chat.
Thank you,
Oh, there
Farida.
is a Bryson Solomon.
There
Please,
is a
Bryson,
question?
can you unmute and say your question?
Yes, Dr. Titus, sorry,
Yes.
this is not about this data, but it was about data cleaning.
Yes.
And my question is, can data cleaning involve changing the format of the data? Let's say, as if maybe data was written in a text format, so that I want to convert it in a way that can be analyzable. So can I change the format of the data? Maybe is that not cooking, right?
Farida, you can respond, or I can respond.
Okay. You mean, for example, if you have text data, for example, maybe education level, and you want to change it into 1, 2, 3, is it something else?
Yes, yes. Maybe there are some data that need to be in numerical format, and maybe during collecting, it was written in a text format or anything else. Can I change it, or I should remove it?
For example, if it is the same example as I say, maybe having, for example, education level, you have primary, secondary, and tertiary, and you decided to give 1 to primary and 2 to secondary and 3 to tertiary, it's not cooking, it's just called recording of the variable. So you just translate from the categories we have into numerical categories 1, 2, 3. That is not cooking. But also sometimes we might convert continuous variables or quantitative variables into qualitative. For example, if you have weight, then you can just categorize it into normal weight, overweight, and underweight. So it's not cooking, it is just a recording of the variable.
Yes, okay, I think
Any
I
other
understand.
question?
Thank you.
Okay, welcome. Any other question? I think there is no question. Maybe we can just proceed.
Yeah, thank you so much for the question. Thank you, Farida, for the response. That was perfect. So we want to import data. Today we'll only end at importing data, and I'll leave the rest of it to you guys. So we'll import data. we'll go to the file, okay? We'll go to the file, and then we'll come here to import, okay? Slowly come to import, and then you can see the different types of data. Now, this is formats, the different formats of data. So from here, you can see we have the Excel format, the CSV format. CSV stands for comma separated values. The CSV formats, the SAV data, the SAS data, and everything else. So Strata, as it advances to higher levels, it comes with improvement. So if you're using Strata 15, you might probably not see a lot of this. You might see fewer than this. So this is now the format of your data. Is your data stored in terms of Excel? Is your data stored in terms of CSV? Is your data stored as a database frame? Is your data stored as a federal something? It's your data in SAS, okay? So, for example, my data is an Excel spreadsheet. So I'll click Excel, and then I'll wait for a pop-up window like so. And then here it tells me browse. So I'll choose where my data is. So I'll browse, okay? I'll browse and see where my data is. So it will take me to the directory where my data is, okay? Take me to the directory. So my data is stored somewhere, course, teaching, it is stored in TAMSA. So I have it here, okay? So I'll click my data here as an XLS and then open, okay? So I can extend this one, okay? You see we have some few dots here, so I can always extend this one here. So you see I am already previewing my data set here. I can preview my data set here. Are together? I can preview my data set. But one thing that we should note is my data set is, the first row contains these names. Now, I don't want these names. I don't want them because these are the names of the variables. And this is not data. Birth weight is not data. Matter age is not data. Matter weight, race is not data. This is the name of this variable. So anything that is on the column is a variable, and anything that is on the row is an observation, okay? So I don't want this. So what I say is import, I'll click in this, I'll check in this box here, okay? I'll check import first row as variable names, okay? Import first row as variable names so that it changes from the first row being names of the variables, but it changes to the first row as the variable names, okay? Look at this. Previously, the first row did not contain the variable names. It contains the A, B, C, D, E, F. These are the common formats of an Excel file. But I want the first row here to contain the variable names. So I'll check this box here, okay? I'll check it. And you can see the transformation. You can see the changes. And then something else that you need to understand is these preserve cases here. So if the wording of the variable names here is in capital letters, you can always change it to lower letters, to lower cases. If it is worded in small cases and you want it to be in capital letters, these words here, the words at the top, you can always say upper, and Strata can always change it. But in this particular case, because the original dataset had row names, variable names as small case, we say preserve, okay? We say preserve. In case where you have them as capital letters and you want to change them into small letters, you will click here and say lower, okay? And I'll recommend you using lower cases than upper cases because it makes it easy working around with. Now, having said that, I'll just click OK. Okay, I'll click OK. And when I click OK, I will see here that my dataset has been imported. And what does my dataset contains? It contains 11 variables with 199 observations, okay? 199 observations. So let us go and see how do we play around with these things here, okay? How do we play around with these things here? So Let us begin with a do file. We should only understand the do file at the moment. So when I click the do file here, okay, I'll have clicked the do file. So it has opened, okay, it has opened. Just because I'm sharing the screen, I cannot have it, but it has opened. Unless I reshare the whole screen. But in the meantime, when I click here, data editor, I will open my data editor where I can edit my data. So let me show you. I hope everybody is seeing this. Are we all seeing this?
Yes, you can see it.
Yeah.
Yes, thank you so much. So this is my data editor here. So in this data editor, I can change what I want. If this 0 is 0 and I want to change it into 1, I can change 1. Okay, that's my data editor. So you should be very careful with this data editor window because you can always change things unknowingly. You can always change things without knowing. So you should always be careful with this. So I can close this from this point here. And you see, the command has been written here. Replace. So our command is replace. Okay. And the variable is called birth weight. And we have replaced birth weight is equals to 1 in row 1. Okay. So we'll come in details into this. So again, browse. I can browse my data. So the reason of browsing data is looking at your data and seeing the nature of your data and looking at, like, browse. I can browse and see how is my data, how does my data look like. Okay, I can see my data looks like, okay, I have the nose here, I have the zeros, I have the years and nose, I have others, blacks, white, everything else. Okay, I have them there. So browse is like looking your data and seeing what is your data, what is your data containing. Okay. And then now these are the windows that we are talking about. These are the variables. So you can see the variables here. So you can see birth weight, mother's age, mother's weight, race, mother smoke, etc. So these are so if you click one variable, for example, mother's age, we can see its properties here. We are told that the name is called a mother's age, and the label is mother's age. It's a byte. So byte is a form of a continuous variable, or it's a form of a numerical variable to say. So numerical variables can be in form of bytes, double, float. Okay. So Stata uses those 3 distinct characteristics. Okay. It uses the float. Okay. It also uses the bytes. It also uses the what else did I say? Double. Okay. Okay. Sometimes you can have the long, or sometimes you can have the wide. But these are the formats of the way the data is structured. So in the meantime, in your way down, you'll always see these 3 different types. You can see a float, or you can see a byte, or you can see a double. This should not disturb you because they are all numerical data. When you see something float, byte, double, understand that it's a numerical data. Have that in mind, and that is enough for you at the moment. Have it in mind that when I see something called a float, a byte, a double, I should understand that it's a numerical data. So we get that from this point here. We get that from this type here. Okay. So if you click another one, okay, say hypertension, we are told it's string. Okay. Anything that is string is a word, kind of, it's a categorical thing. Okay. String are worded variables. Okay. So that is not numeric. So anything that is string, this is str, is string, it's not numeric. Okay. It's not numeric. So you can see this one is byte here. Okay. You can see weight. This is integer. Okay. Oh, I forgot one, integer. Okay. Integer. How do you write it? Integer. Okay. Integer. And what do we mean by integer? We mean a number, okay? So we can have this 4 here. So we can have the integer, we can have the double, we can have the float, we can have the byte, okay? So those are the numerics, okay? So finally, before I leave the room for questions and additions, I want you to go home with 2 commands, okay? I want you to go home with 2 commands. The first command is describe. You can just write here, describe, and then you press enter. Enter is how we run in Starter. If you go to R, there is a button called enter. If you open the do file, there is somewhere on an enter or running. But in Starter, how we do that in a command is we press enter. Okay, so you press enter. So if you press enter, the first command that I want you to go home with is called describe. What does this do? This one describes your data set. It tells you what is all about your data set. So you can see we have the variable names, we have the type, we have the format, we have the labels, variable labels, okay? So we are missing something in between here, value label. So the next session is we'll go and see how can we add these value labels, okay? So we have the variable names, you see we have the string, then we have the variable labels. So this is uterine IRR. We don't know what is it. We'll come and see what is it. So this is birth weight LBS. Okay, we'll come and see what are these. Okay. The second command that I want you to go home with is called codebook. 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 You can always write it here. Code book. Okay. And then you press enter. Okay. If you press codebook enter, you will see a series of your variables will be arranged in a series of arrays. Okay. It's like it will be transformed in a long kind of thing. Okay. So you have the first one, the first variable, and its content down here. Okay. So you'll be told the type of variable. You see, we are having a numeric. It's a numeric variable, but in a subtype of a byte. Okay. So the variable type is numeric and subtype byte. Okay. And it ranges from 0 to 1. So the smallest is 0 and the largest is 1. And if we have missing, we have no missing here. So we would have been told like, okay, we have missing. Do you remember when we imported our data sets? We had 189 observations, and here it's what we have here, 189. Okay. And you are told the tabulation, like how many are zeros? 129. How many are ones? 60. Okay. And you are told the variable label here. Okay. So the same case applies to all other variables. So for example, mother's age, we know this is mother age. Automatically it represents mother's age. So it's a numeric type. It's a byte subtype. Do you have any questions? Okay.
No, we don't have one.
And the range, we know that the lowest age is 14 and the oldest mother is 45 years. So automatically we know this is in years. And we have 24 unique values. When we say unique values, it means we have 24 values which are not repeating. Okay? We have 24 ages which appear once. That is the essence. And we are given some little bit of summary statistics here. We are told that the mean age, on average, the age of all these 189 women, on average, was 23 years. So you see, this one is 23 years, but it has been written as 23.2381. So we cannot say on average the age is 23.2 years. No. We'll say on average the mean age is 23 years, okay? And the standard deviation of 5, meaning we can have women who are 28 and women who are 18. That is the meaning here. The standard deviation is plus or minus, okay? And so we are given the percentiles, okay? We are given the percentiles, the weight as well, So this codebook, it's a command that is written codebook. So you can always look at your data and see, okay, like race here. You see, we are told race is a string. And we can have black. You see, these are words: mother, other, and weight. Okay, those are string variables. And so we have done that by writing here, down here, codebook. Okay, by writing in the command window here. But you can also do that by using the graphical interface here. We can also do the data and then describe. Okay, so you can say data. If you're tired and you feel like, oh no, I cannot type every other time, typing everything, typing everywhere. So if you can always just click. Those lazy guys like me, you can just click. So describe. So you say here, describe data. You just click describe, and automatically you will be asked to describe in memory. Okay, so you'll just say you need to click all the variables here and say click, and then submit. Okay, so you see, when you just submit, it describes. Okay, submit, describes. Unless you want to describe one variable, you can choose it here. Okay, so like here, I've chosen mother age, and then I said submit. So you see, it has described only one variable, mother's age. And we see the command is describe mother age. Okay, if you want to do codebook using the graphical interface as well, you can just say data, describe data, and then describe data contents into bracket codebooks. So you can just click codebook, okay? And once you click codebook, you have a pop-up window here. This pop-up window, if you just say submit, it will codebook everything else. For example, you just say submit, it will codebook all the variables. But sometimes we have 100 variables and we want to just codebook 1 or 2 variables. So you just click from here. You click race. Say, for example, I want to codebook 2 variables, race and hypertension. You click them, okay? If you want to delete, you can always put your cursor here and delete. If you want to add more, you can just click this down arrow or something, and then add one more variable, and then say submit. Okay. If you say submit, you get your answers. Okay. You get your answers here. You see, and the command is very simple, straightforward, easy busy thing. Codebook, race, birth weight. Okay. So you see, we have codebook of these two. Okay. So those are the two commands that I want you to go home with and try and see how you can manipulate. Okay. Try and see how you can manipulate, try and see how you can think around, try and see how we have already shared this data. I think facilitator here or coordinator here, you can tell us where we'll find this data, or if you have shared with us this data, but you have already shared this data with the coordinator. So you can always install it import it into your starter and start using it. Are we together? So for today, unless Farida has something to add, but for today we'll end up here, and tomorrow we will pick up on something. But one thing that I've just remembered is in starter, we have data sets. You don't need to request data from people for your own exercise and practices. You can always have data from starter itself. And how do we get that? We get that from file. Okay, file. And then you can go to example datasets. So example datasets. And so it will give you, I hope everybody is seeing this. It will give you example datasets. Okay. So you just need to click example datasets. And then here we have the description. Example datasets installed with starter or manual datasets. Say this page contains links enabling you to describe or use datasets that were installed with starter. This spread provides access to all datasets referred to in the starter documentation. So you can say, for example, example datasets. And you see, we have a lot of datasets here. So all these are data sets that we have, okay? So you can say use. If you say use, it will go automatically to starter. For example, you can say use, okay? Use, and if we check into our starter, we will see that it is restricting us from using. Why? Because already there is another data set that is present. So what we need to do is we need to clear this information here, okay? So how do you clear? If you want to clear this data set, you just write a simple command called clear. If you say clear, it will erase your data. So clear. So we have no more data set here. So we'll go to File, Example Datasets, then Datasets installed with starter, and then say Use. So before you use dataset, you can describe and see, is it meeting your needs? So you can say describe. So if you say describe, you will see we have described auto dataset. So these are now a dataset on cars and something like that. So we have described that on the price of gallons and oils. So we have described that dataset. And so if you want to use it, you can go back to example dataset, datasets installed with starter, and say use. So if you say use, you can see we have datasets that has popped up here. Okay. So that's how you do it. So you have a lot of datasets that you can use here. So you can also use all these datasets. In the meantime, for tomorrow's exercise, I want you to go and use the NLSW88.DTA dataset. This one here. Go and use this dataset and describe and say what is contained in this dataset. So for your practice between now and tomorrow when we meet, you can go and look at this NLSW88 dataset and use it and see what is contained in this dataset. Okay. If you have any problems in starter, you can always write help. You can always write help, and help will tell you a lot about what you want to know. So if you want a command, so you can always say help. Okay, you can always say help, describe. Okay, help describe, and it will tell you what is all about describing. It will give you examples. Okay, it will give you examples. It will give you so much things. Okay, you see, we have examples here, and everything else, and everything else. So having said that, thank you for listening, and thank you for attending today's session. Unless somebody else has a question. Thank you so much.
Thank you everyone for participating, but there is a question here from someone called Eman. Can you speak it out?
Okay, thank you very much for a very practical presentation. I had a question. Recently, I have been trying to analyze data, and on the cleaning part especially, and the edge had month, and it also had years, meaning there were children who are less than 1 year, and then there are children who are up to 13 years. So I was asking, when you are cleaning your data, do you put that in decimals? Are you allowed to put that in decimals? And when you calculate maybe the measures of like average, can you say the average age is, let's say, 5.2 because you calculated the months in decimal points? Is that acceptable? Thank you.
Okay. In data cleaning, also there is that you can just, I think you have to use one measurement. If it is in months, then you can just put in decimals. But if you want to put it in years, that is where you can just add decimals for those who are less than 1 year. And sometimes just maybe 5 years and 6 months. So it can just be 5.5. Or if you decided to put it in a month, then all the data sets should have all that variable in our observations should have those observations in months. So if it is 5 years and we expect it to be 60 months, so it's you as a researcher, you have to decide whether you want to put it in a month or in years. And if you put in a month, that means for those who are less than 1 year or having certain years with certain months, then it has to be in decimals.
Okay, thank
I
you.
think I
And
responded.
yes, and maybe the last question from me is there was a time when I left, so maybe you spoke about it, but I didn't hear. But I wanted to ask the cleaning. Do you do it like in an Excel sheet and then import it into Stata, or can you like do the cleaning within Stata?
It is possible to do it in Stata, as Mr. Titus showed. There is a certain data editor. You can just edit your data and so on. So you can just do it in Stata. But first you can just browse it so that you can just edit mistakenly. You can just browse it and see if there is anything that captures your attention that you will just need to edit it. Then you just go to data editor, then you can just edit it. So it's not a must to do it in an Excel, but you can just do it in data cleaning, data analysis, and everything.
Okay, thank you. And sorry, last question, I promise. When you let's say submit your paper, let's say for publication, do they
Yes.
normally ask for the raw data set? Do they ask for the cleaned data set, or do they altogether don't ask for it?
It depends on certain journals. Certain journals they ask for data sets, and some journals do not ask about the data set or edu file or scripts. But some journals, I don't know about the command, but what I know, some journals require data set and some journals does not require any data set.
Okay, but if they ask for the data set, you give them the one that you cleaned. Yeah?
Yes.
Okay, thank you very much.
Welcome. Any other question? Silence means there is no question. So let me thank you once again for your participation and active participation. It was just an interactive session. So we thank everyone. So let us meet tomorrow, I guess. So be here while you are doing the assignment about the cleaning, and we can just give a directive for the first few hours. Thank you so much. Maybe if your host has anything to say.
Well, thank you, Madam Farida and Mr. Titus, for the nice presentation. Well, we have read a lot today, and I would urge you, everybody who has joined today's session, to work on the assignment which you have been given, because data analysis without practice is like not doing something, not learning something. So as Mr. Titus said, data analysis is a continuous learning process. So we have to learn every day and practice every day. And data analysis is like programming. You have to do every day in order to remember what you have taught or learned. So I advise you to practice more, continue practicing. Don't just learn today and leave it apart. So you have to do practice every day. And lastly, I would like to get feedbacks from you who have joined today's session. There is a form here. I will share for you to fill out for the today's session. We just need a feedback from you on today's session. How was it, and where can we improve? So, with that being said, thank you everyone who have joined today. Till we meet again tomorrow.
Kesho ndio mapema. Okay, thank you everyone. See you tomorrow and have a nice evening.
I'm expecting calls hapa ambapo get the call kazini siku na shule hiyo moja.